Hello, welcome to the inheritance activity. I'm your host, Pippin Bar, and what I want to do is the usual, right? We've got a specific activity for looking at inheritance and a particular kind of full program that uses inheritance, and I'm just gonna try and do it, and I'll explain what I'm thinking while I do it. So let's get started. Okay. Let's go look at the actual activity text, which is over here on the website. The objective's pretty simple, just using inheritance in a kind of sensible way to see how it works. And I'm going to keep with the theme of the previous lectures, which is around this idea of traffic. And what I want to do is build a fairly similar model of traffic. So we're going to have cars, trucks, and motorcycles moving left and right across the canvas. So there's kind of like a vision of traffic. And we're going to introduce a pedestrian who's going to try and cross the road. That's who the user is going to control. And if they get hit by a car, then obviously they die. And if they cross the road, then that is big success, just like life. So we can understand various things that we need to do from this. But let's begin, as always, by creating our project. So I'm going to download the template project. I'm going to unzip it. I am going to go to my downloads folder, which I guess is here. That didn't work. Here. And it's not there because it's on the desktop. Foolish me. So let me go to my repository in my GitHub folder, and let me go to my activities folder, and let me grab the template from there. There we go. And I've already forgotten what I was going to call it. I think I was supposed to call it inheritance activity. So I'll call it inheritance activity. Like that. Perfect. And that's it. Now I need to open this in Atom, right? So that I can begin work. Pow. Done. Nice and green. All of the green, fresh new files and folders. The correct thing to do now is to commit this, so started inheritance activity. And maybe I'll prefix that with activity. Commit and push just for good measure. So we're ready to begin. I've done all of these steps here and create a new project. This is so familiar to you that I didn't think I would go through it step by step anymore. And now we need a plan. So as always, I've got a sort of a way that I'm planning on doing this based on which I've written into the activity. You're welcome to try and do it in other ways. But the way that I'm going to approach this today is I'm going to start with a basic main script that has different states that are going to reflect how the program works. Then I'm going to create the pedestrian and integrate it so that I can move a pedestrian around early. That's just going to be a little controllable circle with the keys. Then I'll create my keys superclass, the vehicle class. This will probably be fairly familiar. And then I'll create some subclasses, car, truck, and motorcycle, to create some variety both visually and behaviorally in the program. I'll integrate all of those kinds of things into the main script so that we end up with an actual traffic simulation and a pedestrian simulation, but they won't interact at that point, and so the final thing is going to be kind of pulling everything together and making the pedestrian and the traffic interact, which sort of euphemistically, the traffic will kill the pedestrian, as well as trigger the two different ending states, just so that we have a kind of a full experience. So that's the plan. I'm going to go through some of this stuff a bit more quickly, just because it's already fairly familiar at this point. In particular, this idea of a main script with states. So I'll just point out that what I need is I need a title state, a simulation state, a success state, and a dead state. So I need to track that in a state variable, and I need to switch between them. I'll come back when it comes to the text stuff, because I'm going to write a specific function for displaying text. So let's head back to the program, and let's open the script. As always, we've got some basic stuff here. I always feel like guilty, so I'm going to say pedestrian palaver. And I'm going to write a short description. You should always write longer descriptions. A traffic simulation where the user is a highly endangered pedestrian trying to cross the road. I'm going to forego writing these comments above functions just for time, so you don't need to watch me typing descriptions. But again, that's always the right thing to do, right? So let's begin. I'm going to be working with states. There are different ways to do states. In particular, there's a very nice object-oriented way to do states, but I'm going to leave that aside for now and focus just on a fairly simple version of that. So I'm going to start out in the title state. In setup, I'm going to create my canvas. I guess I'll just make it, should I make it 16? I'll make it the full size. I can't remember whether there's any particular reason to do it one way or the other. That seems like it'll be fine. And I'm going to fill the background, and then I know that I'm going to have states, right? So I can either write the state functions now, or I can write my if statement now in the draw. Either way, I'm going to be kind of making assumptions, right? I'm going to either be assuming that I've defined my state functions when I write the if statement, or I'm going to be assuming if I write those functions that I'm going to be calling them somewhere. It feels most natural to me to fill in draw first, so I'm going to write my checks here. So if the state is title, I'm going to call a method, a function called title. Clearly this doesn't exist yet, but I'm going to keep writing draw before I define it, just because I know what I need to have here. Ooh, that was aggressive. Because I know what I need to have here, right? So I'm just going to check all of the different states. If it's simulation, I'm going to call a function called simulation. If the state is success, then I'm going to call the state called success. And if the state is, what did I call it? Dead, I think is what I was going to call it. Then I'll call the state called dead. Clearly this program doesn't work because these functions don't exist, but you have to do something like that, right? So it's completely fine to call imaginary functions knowing that you'll define them. So now I need to fill in my different states. I may as well write the definitions for all of them. So I need a simulation function. Goodness me. I need a success function, and I need a dead function. Currently, obviously, this still does nothing, but now this is at least a working program, right? Well, it has no errors. I should probably check that. I shouldn't just claim it has no errors. Let me start and see what it does. So it's black because I filled the background. Let's just go have a quick look in the old console. No errors there, just a few kind of audio issues and so forth, as we are pretty familiar with. Good, okay, I'm happy with that. Let's go back to the instructions. So we got here, defined the function. So I did these two things in the opposite order, right? I wrote the if statement first, and then I defined the functions. Doesn't matter which order you do that in. Now, to be tidy, because my title and my success and my dead states all need to display some text on the screen, it makes sense to write a function that displays text. So the display text function is going to take a text parameter, and it's going to display whatever the string is in that parameter in the center of the screen with some text settings. So let's write that function. I'll write it at the end because they're all going to use it. So it's going to be called display text. And the parameter, I could call it text, but it's actually not a good idea to call it text because this will have a conflict with the text function that I need to use from P5. They'll kind of butt heads, and what will actually happen is that this text here will end up replacing the text function because functions and variables share the same kind of naming space. So I don't want to call it text. I don't want to name it after any functions in P5. Instead, I'll call it string. That seems like an okay thing to call it. And I'm going to push and pop around this because that's always the right thing to do when I'm displaying. And I want to set a few basic text style properties. So I'll set an align, I'll set a size, I'll set it to 32. I'll set a fill, it can just be white. Yeah, why not? And then I guess that's enough. I'll just display, there's probably something I'm forgetting. I'll display the string. So I use the text function. I tell it display whatever string is passed through here to my display text function. And I will display it in the center of the canvas. So that's done. Then it remains to obviously call this display text function in my various states that, you know, all they do is display text. So display text. What's the title? What is the title? I called it something, didn't I? Oh, I called it Pedestrian Palaver. It's probably a really stupid name. Pedestrian Palaver. And then display text. For my success, I want to also display a text. Oh, I forgot my semicolon. Oh dear, I'm looking. Oh, there's a winking face saying, you screwed up. What is it when it's success? You cross the road, so let's say you made it. That is what it can say if you get across the road. And if I die, you died. So sad. So those are my three states. So that's completed the title, success, and dead states for the purposes of this program. Because we start in the title state, I should be able to see the text displaying for title. So that's a good way for me to check whether my display text function is doing what it should do. Is it? It is. So we get the title, and it says Pedestrian Palaver. Wonderful. I feel like yeah, there we go. I actually I modified this. I just reloaded the page there to get some stuff that had been updated. In particular, I think it makes a lot of sense to add a keypressed function so that we can switch to simulation from the title state. So we want a keypressed that checks if the state is title, and if it is, it switches to the simulation state, just so we can get out of that title screen, right? So we'll add that right at the bottom. Function keypressed. So if a key gets pressed, and if my current state is title, then I want to switch my state to simulation, so I can get out of the title state. Again, this is something I can test right away. If you make a change to your code and you can see or experience the difference of it right away, you should always just go and check, did it work? So let's go and check. So there's the title state, and if I press a key press, the title goes away. We're in the simulation state, right? But because there's nothing in the simulation state, we just see the black background. But we can tell it worked because the title disappeared. So that was worth checking. Okay, that completes step one. We've got our basic framework for switching between states, and we've got our 4 states defined, and we've got text to display. So let's start doing something more funner, which is to define a class which contains a user-controlled pedestrian. So the steps, you can see there's the steps there, but let's just do them one by one. So first, create a class file and link it in index.html. So we're going to create a pedestrian class. So to do that, I like to right-click on JS and do New File. And I'm going to call it pedestrian.js. That's the file. And the first thing I like to do is just define the basic structure, class pedestrian. And then I like to immediately go into index.html over here. And while I'm here, actually, may as well change this title, right? There's no reason why it should be called template P5 project. So pedestrian palaver, exclamation mark. Sounds like a real old Atari game or something. To link my pedestrian.js script, I know that I need to put it in here, and I know that I should include it with a script tag before the script, because the script is going to use the pedestrian, so the pedestrian needs to be above the script. It needs to be defined before the script comes up. So that's that done. So our pedestrian is now part of the program. Now we need to actually go through and define what a pedestrian is and does. So we've done step one, add the class structure. We've done that as well. That's just kind of a default thing that I think it makes sense to just do automatically. So now we want a constructor. The pedestrian is going to be a thing that moves around. So it's going to need a position, a velocity, and a speed. If we're going to see it, it also needs a size. And if it's going to die in traffic, tragically, mourned by none because there's no other people in the simulation, sad, it's going to need like a property that tracks whether it's dead or not. So let's go through and define all of those properties. As you can see, I've kind of spelled it out here, but I'm just going to do it by thinking about what I need to do. So in order to create a pedestrian, we need a constructor. So let's create a constructor. It makes sense with a pedestrian and with many kinds of things that we're going to display on the canvas that we would want to specify when we create it where it should go. That just gives us flexibility. And we could add lots of other stuff here like size and speed and stuff as well if we wanted to. I'm just going to limit it to X and Y. Then I can go about creating all of my properties. So I'm going to set X to whatever is passed through as the X parameter, and similarly for Y. Then I need a size, because I want to be able to see this thing. It's a circle, which is why I just specify a size. I'm forgetting what a reasonable size is. What did I suggest over here? 20, sure. Okay. And I'm going to set velocities. They're going to start as 0, because we don't want the pedestrian to be moving at the beginning of this simulation. And I'm going to set a speed. Because I'm going to be controlling the pedestrian with the arrow keys, I need some way to tell it how fast it should move when I hold down an arrow. I will set this to what? What am I telling myself to set it to? 5. Okay. And finally, because the pedestrian can be dead, I'm going to have an alive property that starts out as true. I could have a dead property that starts out as false. It's kind of up to you. It's sort of feels a bit more positive to track its aliveness, since that's what it's going to be at the beginning. So there's our constructor. We can basically just create a pedestrian and set its properties that it needs to exist in our little simulation. Then we're going to need to define the methods that make the pedestrian what it is. And you can see we're going to have handle input, move, and display. Handle input, we're going to move with the arrow keys. So our handle input needs to basically, you're probably already very familiar with this, but it needs to check which arrow key is pressed. And if one of them is pressed, it needs to set the velocity appropriately. So I'm going to go ahead and just do this off the top of my head. So the method is called handle input. No parameters needed because it knows which keys it's going to check. You could, if you wanted to, specify the specific keys that a pedestrian is going to use, for example, in its constructor, and even pass them as parameters as a way of making multiple parameters with different keyboard controls. I'm just going to have one. So what do we need to check? We need to check if a specific key is down. And we know that P5 has a key is down function that we can pass a key code. I don't have to remember the key code, for example, for the left arrow, because there's already a special variable defined called left arrow that contains the key code for me. Thank goodness. I cannot remember what it is, 65 maybe or something. If the left arrow is pressed down, if this if statement is true, then I want to set the x velocity to go to the left, which would be negative speed. Then I need to check, if that's not true, then I should check is the right arrow pressed. That's the other possibility that matters to changing the speed. If it is, then I want to go to the right, which is positive speed. If neither of those two are pressed, I'm going to set the velocity to 0 so that the pedestrian would just stop if I'm not holding one of those arrow keys down on the X. And then same thing for the vertical, right? If it's the up arrow, then the Y velocity should be negative, and we'll use the speed property so we can control it easily. And if it's the down arrow, then the Y velocity should be positive, and otherwise the Y velocity should be 0. Done. So that handles the input. Very, very standard block of code there. Next is a move method. We just want to update position with velocity. We've seen this 1,000 times. So let's write a move method, and we want to update the x property by adding on the x velocity. I'm using plus equals here, just it's a little bit more common to use this kind of shorthand. So add the x velocity to the x position. Same thing for y, if I could avoid making typos. So move is done. That's just the standard issue code. We're not using acceleration or anything. Finally, display the pedestrian. Makes sense to be able to see them. We could do all kinds of fancy things, but as I said, I'm just going to write a display that displays the pedestrian as a circle for time. So display, always push and pop. And then in here, some styling stuff. We could make the pedestrian a nice kind of pink color, maybe like that. And no stroke, because pedestrians don't have strokes. It would be too cruel that they're also having a stroke while they're trying to cross the road, wouldn't it? Oh dear. Okay, and then we want to draw an ellipse at the position of the pedestrian, which is this.x and this.y, with the dimensions of the pedestrian, which is just this.size. And there endeth the lesson on the pedestrian. So we've got our key methods and properties. It's a very, very simple, standard issue kind of a class. Doesn't do a lot of stuff, but it does allow us to move this particular kind of thing around on the screen with the left arrow, right arrow, up arrow, down arrow. So it's written, it's integrated into index.html. It remains to integrate it into the main script, right? I believe that's the next thing. Yeah. So we're going to add it to the main script. In order to kind of, because we're now basically working on the simulation, it makes sense to now change the default state to be the simulation, so we don't have to go through the title every single time. Little things like that are a really good idea just to speed up your development process. I'll talk about another one of those later if I remember. Then we're going to add a pedestrian variable. We're going to create a new pedestrian in setup. This is very standard. Importantly, we want to put our pedestrian at the bottom of the canvas because it needs to cross the road from the bottom to the top. That's how the simulation is going to work. And we need to call all of its methods in draw, in the simulation function, of course, so that it can do its pedestrian thing, right? So let's do that. Back to the main script. Up to the top. So we've got a state. I think I'll leave the state at the top today. I'm feeling I'm going to live dangerously. Now I want a pedestrian variable. And in setup, I'm going to create my pedestrian. So pedestrian is assigned a new pedestrian. Where do I want to put it? Let me define a couple of variables for this. So its x is just going to be the center of the canvas. And its y is going to be at the bottom of the canvas, which is height. But I should subtract some amount so that I don't end up with the circle like right off the bottom. Or I could, it's fine actually, you know what? Because the circle is drawn from its center. So if I position it at height, we'll see the half of the circle sticking up from the bottom. Seems good enough. Then I can pass those two variables as my arguments into the pedestrian. So that creates the pedestrian. The final thing that we need to do is in our simulation. Very exciting. We're going to start actually doing stuff in the simulation finally. And I'm sorry, I'm thinking about something else, but I'm just going to leave what I was thinking of alone. It's very tempting to do all kinds of stuff, isn't it, when you're programming? So I need to call the methods, right? So pedestrian.handle input is the first thing it should do. It should check whether any of the keys are being held and update its velocity. Then after it's checked that, it can move, because its velocity might have been changed by handle input, right? So it makes sense to call that first and then call the move method, and then we should display it on the canvas. Those are our three things that we want to do. And now, all going to plan, which it sometimes does. Oh, I forgot to do the thing I said was important. I forgot to, oh, well, that was cool. I forgot to change the default state to simulation. That's just to speed things up, right? So I don't have to go through the title every time. So that we see a little dot and it moves. Whee! Very easy to cross the road, right? Woo! Made it. Going back for seconds, crossing the road. Anyway, you can see I can move this little circle around on the screen. There's no traffic. It's as if we were in a post-apocalyptic world where there's no traffic anymore. And we can cross the road easily. Not like in real life. Okay, satisfying, already satisfying. Part 1, and part 2 actually, is complete. Now we get on to introducing the horrible world of cars on the road, which is going to be bad for our pedestrian. So we want traffic, and a way of thinking about this, if we're thinking about a simulation like this, and we're thinking, well, we're going to have traffic, and we're going to have different kinds of vehicles, cars, motorbikes, and trucks, in our case, it makes sense as a programmer to think, well, they're all going to be very similar. It's likely I should write a superclass that can take care of a bunch of the commonalities between those three different things. We happen to have already talked about this, but it still would make sense even if you were doing something brand new to think in that way, right? Like, are there commonalities? Should I define a superclass? Yes. We should define a vehicle class that takes care of common stuff and extend it to create the subclasses to write a better program. So here's my definition of a vehicle. It's a rectangle. It can move horizontally at a set speed, left or right, and it should wrap when it reaches the right or left edges of the canvas. So if it reaches the left, it should wrap back out over to the right, and so forth. And that's it. That's what we're going to do. Again, there's specific steps here. I'm going to try and remember them and see how we go, because this is, again, a fairly common set of things that we're going to do. So first, create the class. We've done this many, many times. Let's create a new file, call it vehicle.js. Write the basic little class structure, class vehicle, and link it in the index.html. I'm going to put it after the pedestrian, vehicle. Vehicle. I don't really need pedestrian open now. What's next? Add class structure, add a constructor. So we know the kinds of things that we need here. We need a position, a velocity. We need dimensions, even though a vehicle is not something that we will display specifically. It makes sense to define the fact that a vehicle has dimensions in this particular class, and it will have a speed. So let's create all of those things. So to do that, we'll have a constructor, of course. Again, makes sense to specify where any individual vehicle is going to be positioned. And then we go into the setting frenzy. set its position to the parameters, set its width to undefined because it does not have a width, it's just a superclass. I almost wrote underlined there. And, oh heck, what else was, oh, and a velocity. That can just start as 0, it's not moving when it is born. Maybe that's it actually, is that all? Oh, a speed. It makes sense to have a speed. This will also be undefined because a vehicle is an abstract idea. It doesn't have a specific kind of maximum speed, unlike the specific subclasses that we'll create. So there's my vehicle and its properties. Move method. We know all about move methods. Goodness me, do we know about move methods. We know that we should add the velocity to the position. And you know what? If you were thinking about this, you might start to think that a vehicle and a pedestrian are kind of similar. A pedestrian, the way that we're treating a pedestrian is almost a kind of vehicle. So we could even have thought about making the pedestrian a subclass of vehicle if we wanted to. That would be interesting. I'm not going that route in this particular case. I think there are reasonable reasons not to, but it would also be reasonable to make the pedestrian a subclass of a vehicle. Just because of the way we're thinking about the pedestrian. Okay, wrapping, we want to wrap on the left and right, so let's write a wrap method. Wrap, though, what am I doing? So I want to check if its x position has become greater than the width. It's gone off the right-hand side. I'm going to subtract the width from its x position, so it will zap back to the left-hand side. And otherwise, if its x position has become less than 0, it's gone off the left-hand side, then I'm going to add the width to its x position to make it teleport across to the right-hand side. And that way, whichever way a car is driving, leftwards or rightwards, it will reach the edge of its canvas and then zap back across to the other side. So we get a wonderful world of infinite traffic. Sounds depressing, but that's what we've got. And a vehicle, I've discussed this before, but we want to have a display method even though we're not going to put anything in it because we want to say that all vehicles should be able to be displayed. And by putting the empty method in here, we're saying to anyone, including ourselves, who extends this particular class, this vehicle class, you should include a display method. All vehicles should have a display method. And this just makes our programming better because it gives a kind of a guarantee that this is a thing that vehicles can do, which works well for things like polymorphism later on when we want to know that a vehicle can be displayed, for example. Okay, so we've got our vehicle class. That's all done. Should be good. It probably makes sense for me to pop over here and just make sure that there's no errors in my vehicle. There are not. Nothing showing up yet anyway. Now we want to create our subclasses, car, truck, and motorcycle, with different sizes and different speeds. So let's look, looks like we're going to do this kind of in detail for car. So let's create a car class, and we'll make it extend the vehicle class. So again, add a new file, call it car.js. Define the class. Now here we don't just say class car, we say class car extends vehicle, because a car is a kind of vehicle. It's a subclass of vehicle, so it's going to inherit all of the properties and methods that a vehicle has, plus whatever it defines for itself. Whatever I define for it, really, right? And right away, of course, I should then be adding this to index.html. I know that I want to add it after vehicle because the car depends on the vehicle. It extends the vehicle, so it should be defined after the vehicle. Now what? Add a constructor. Call the super constructor, so it sets itself up as a vehicle, and then set a specific width and height and a specific speed. Okay, so those are going to be the kind of specific differences between a car and a generic vehicle. So let's do that. Constructor. Because we know that a vehicle needs an x and a y, it probably makes sense to generally have the same parameters here. We might have more parameters, but it rarely, sometimes it makes sense to have fewer. In this case, I think it makes sense when I create a car, I'm going to give it its position. And what will it do with that x and y? It's going to call the superclasses constructor, which we do by writing super with parentheses after it. That's calling the vehicle constructor, and we're going to pass along whatever those parameters were set to. So when we create a car, it gets a position, and it gives that position to the vehicle constructor to set its position properly. Then we want to set the specific properties of a car that it needs to have its car-like existence, which is a width, I believe I said 50 and 20, did I? 50 by 20? Yeah. And a height, 50 by 20, and a speed. It's going to travel at 10 pixels per frame. So that's what makes it car-like, right? Super with the XY parameters is what makes it a vehicle, sets it up as a vehicle, and then these are the specific car things that it modifies the defaults from so that it is a car. Okay. Oh, it looks like I made it a bit fast. I'll make it 5 because this is going to matter when I'm trying to walk through it as a pedestrian, as we shall see. Add a display method. This should just display it as a rectangle. Okay. You could also make it like look super cool if you want to, but I'm going to draw a rectangle because I don't have time for this silliness. So a display method. Remember that our car by default gets the move and wrap methods of a vehicle, so we don't need to define those here. We are defining display just because the vehicle doesn't do anything in its display. Nonetheless, I should say, we should always call the super method, so super.display in this case anyway, just in case later on we do stuff in the vehicle's display method. We want to keep the car as being as vehicle-like as possible. So it should call the vehicle's display method even if it doesn't do anything, because that continues to say, well, the car is a kind of a vehicle. So it displays like a vehicle, and then it does its own special thing, which is that it's going to draw a red rectangle with no stroke. Cars can't even have strokes. It's going to draw a rect at its position with its dimensions, like that. That's how you draw a car, right? In my terrible, lame little world. You could do all kinds of cooler stuff than that, draw wheels and stuff, but I'm just not doing it. Okay. Hopefully that works. As there's no real way to tell, right, with stuff like this, whether it's working. You can go and check in the JavaScript console, and if there's syntax errors, you will probably see them there, but until you really use it, you don't really know if anything went wrong. Despite that, we're going to plunge ahead and define truck and motorcycle. They're just going to have different dimensions and speeds. For that reason, what I'm going to do to create them is I'm just going to duplicate the car. It's a little bit cheesy, but we know that they're so similar that there's no reason not to. So I've just created a truck class. I'm going to change its title to truck. In the constructor, this is the car version, I'm going to say that it's 100. No, that's a bit big. 100, I'll keep it the same height. So it's, 80. 80 by 20. And it's going to be slower. Maybe I'll make it go at 2 frames. I forget what I said down here. 2 frames. That's slower, but that's fine. 2 frames per, 2 pixels per frame. I'm sorry. And it's going to draw itself. Now, there's reasons to think that I probably should be drawing, doing the display in my vehicle, just because you can see it's like super, super similar. All that I'm going to change is the fill, which is a bit lame of me. But just for now, I'm just going to keep it like this, okay? I apologize to you. I'm going to give it a fill of 200, so it's just kind of boring and whitish. I feel a bit embarrassed about how similar this display method is, but for now, it's just easier to do it this way. If I were refactoring, I would notice the similarity, and I would either have a fill property up here. That would have been a good idea. Or, you know what, no, I'm not going to do it. I'm not going to do it. Don't talk me into it. How dare you? I'm just going to keep it this way. I would either normally have a fill property up here, in which case the display could live in the vehicle, or I would display the rectangle in vehicle, and I would just set the fill in my display method here. However, I'm not doing it that way, so there's a bit of extra repetition that could easily be erased. I won't think about that too hard. I feel bad about it. I just created a truck file, so I do need to add it here into my scripts. Again, it has to be after vehicle because it extends vehicle. Then we need one more. I'll duplicate truck to make my motorcycles. Rename the class to motorcycle. What have I done here? I duplicated the wrong thing. That was silly. I'm going to delete that and start again. Delete motorcycle.js. Yes. Duplicate truck, which is what I was trying to do and failing to do, to create motorcycle.js. Goodness me, what is going on here? No, naughty. I've messed up again. I'm going to delete this again. this happens. So again, like I accidentally, when I left the motorcycle.js file open after kind of deleting and then recreating it, because I left it open, it just kept all of the data that was already there. So that was silly of me. One more try. Duplicate truck. Call it motorcycle. Now it's open. There we go. So this is what I wanted, right? I want to be able to just edit the truck into a motorcycle. So change the class name, change the width. It's going to be little and fast. Is that too silly? 30 by 10, is that good? Yeah, 30 by 10. And it's going to be faster. So it's going to move at 10 frames, 10 pixels per frame. Dear God. And it's going to be yellow. So 255, 2550. We won't talk about the display thing again. And I need to add it here. Again, after vehicle, but before the script. After the thing it uses, before the thing that needs to use it. And there we go. We've created a motorcycle, a truck, and a car, and a vehicle. We're ready to get into the real business of the traffic. So, big step. Add cars, trucks, and motorcycles to the main script. And we know how to do this. We're going to need an array. We're going to need to put our different kinds of vehicles into that array, and we're going to need to do a for loop in our simulation to update them with their methods. So let's do it step by step. So the first thing is we need a vehicles array. Thanks to polymorphism and the fact that we have a superclass vehicle, we can put all our cars, all our trucks, and all our motorcycles into the same array because they all behave as vehicles. And we can also then, we will just need to define how many of each we're going to have as variables as well. So let's do that first. So we've got our pedestrian. Let's create our vehicles array. Plural S there. Plural vehicles, because generally there's going to potentially be more than one. And then num cars, let's say 10, num trucks, 10, and num motorcycles, 5. I mean, depending on how we tweak these numbers, it's going to be easier or more difficult for our pedestrian to live a long and happy life. Okay, there's our variables. Create our 3 kinds of vehicles in setup. So this is where we need to write for loops that count up to the various numbers that we asked for, and to then create each different kind of thing. I'm going to position them randomly somewhere on the canvas. We could be fancier than that. We could also be fancier. We're going to need 3 for loops, one for each particular kind of thing. There is a fancier way of doing that, but it is also a little bit mind-bending. And so I didn't want to kind of do it in this activity. So let's do that. So that creates our pedestrian there. Then we need a for loop, right? So we need to count from 0 up to the number of cars. So we're going to do the cars first. And we're going to make our random position, random 0 to width, and our y, random 0 to height. And then I'm going to make a car. New car with the x and the y that I just created. So that creates a car. We know that it's also, in effect, creating a vehicle. And then I want to add that to our vehicles array. I'll use push car. Push is good here. Push is especially important here because I don't want to use the, there's that thing I could do where I could say vehicles I, and I could assign car to that. That won't work because I've got multiple arrays, multiple for loops where I'm adding different things into that array. So I really want to use push here because push doesn't care about the specific index. It just adds it to the end of the array, which is actually more useful. So if that's car, I need to do the same thing for trucks. And I'm just going to duplicate the for loop and replace the bits that need replacing. So num trucks sounds a bit like nunchucks. I need to change the variable that I'm creating to truck. I need to change the constructor that I'm using to truck. And I need to push the variable called truck there. Again, repetitious for sure. There are ways to reduce repetition here, but it's not super important. The clarity here is not the worst thing in the world. And I'm happy with this, to be honest. I think it's okay. It would obviously get more and more tedious the more different classes I had. And at a certain point, I would think about doing something a bit more sophisticated. Num motorcycles, we count up there. We create a motorcycle there. We make sure to call the motorcycle constructor, and we make sure that we're adding the motorcycle. Now, that's good. So that's done. even just this small amount of repetition, you can see that there's potential to screw things up, right? If I miss converting a truck to a motorcycle or something, I'll end up with an error of some kind. But you know, it's not terrible. So we've done that. There's another thing I want to do. I don't want all of the vehicles to move in the same direction when it starts. I would like some going left and some going right. There are different ways to achieve this. As I say here, literally. We're going to have a for loop after we've created all of the vehicles and added them to the vehicles array, where we're going to go through the vehicles array and we're going to randomly choose whether each vehicle should go to the left or to the right. And we're going to randomly choose by creating a random number between 0 and 1, and then checking, is it less than 0.5? Because half the time it will be less than 0.5, and half the time it's going to be greater than 0.5. So we'll end up, roughly speaking, with half the vehicles going left and half the vehicles going right. So let's do that. Also in setup, right? So this is my set random directions code. So a for loop, again, this time we're going to count up to vehicles.length, all of the vehicles that we've added, which is 25, I think, right? 10 cars, 10 trucks, and 5 motorcycles. And for each one, we're going to create a random number. I'm calling it R. You could call it different kinds of things. Random number between 0 and 1. And I'm checking, is it less than 0.5? Because if it's less than 0.5, then I'm going to make my vehicle go, let's say, left. And to do that, I need to let me think about this. I still prefer pulling out the vehicle into a variable like this. So I declare a temporary vehicle variable, and I put the vehicle in the array at index I, at vehicles I, into that variable. It's just a clarity thing. You don't have to do it, but I kind of like it more. So I'm going to set that vehicle's velocity to be the negative of its speed. So it moves left. Otherwise, if R is not less than 0.5, i.e. it's greater than or equal to 0.5, I'll do the opposite. I'm going to set its velocity to positive speed. There's an argument for making this particular thing into a method on vehicle, like a method called left, for example, and a method called right. I'm doing this just for speed. Okay, so that will go through all of my vehicles and give them a random left or right velocity. So we've created them all and we've given them their random directions. It remains to actually make them activated in the simulation, right? So in the simulation, we need to go through every vehicle with a for loop, and we need to call move, wrap, and display on each one. Let's do that. So in simulation, down here, there's the pedestrian. Let's do the vehicles. So for let I is 0 up to vehicles.length, the standard for loop that counts through an array of things where we want to do something to each one. Again, I prefer to do it this way. Get the current vehicle that the for loop is looking at, which is the one at index I, and do the things with it. Vehicle.what? Move, vehicle.wrap, and vehicle.display. Okay, so now simulation updates both the pedestrian and the vehicles. And unless I'm mistaken, we should be able to run our traffic simulation. So let's go look at it. Oh yeah, that's good. So you can see I can now play what is effectively kind of like a game of Frogger. I can avoid these traffics, and I can cross the road because I'm a genius. However, it's not as interesting as it could be, right? Because currently, if I do run into a car, it doesn't really do anything. The other thing that is irritating me is that as I press up and down, you can see the page is scrolling a tiny bit. I'm just going to go and quickly fix that. That is something I can do in my CSS. And what I can just do is in the body, I can set overflow, which is the thing that determines whether you can scroll or not. And I'm going to set it to hidden, i.e. don't show me anything in the scrollable area of the page. And by doing that, now you can see there's no scrolling as I move up and down. However, the main thing that I need is not a little aesthetic nitpick, which is what that was. It is the need for these cars and the pedestrian, these vehicles and this pedestrian to collide. So that's the big next final thing. So it's sad but true. We want the pedestrian to be hit by cars because we're sadistic. So the things we're going to need, we need some way of checking, did the pedestrian get hit by any of the cars? So we're going to need a method in the pedestrian class that is able to check, was I hit by a specific vehicle? And then we are going to check against all of the different vehicles in the vehicles array. Did the pedestrian get hit by this particular vehicle? Check for every single vehicle. And if it did, then the pedestrian is going to be dead. And then also, in order to be able to succeed at crossing the road, we should check, did they make it to the top of the canvas? So let's do that. I've actually put in the code for this here, just because it's, it can be a tiny bit tricky to think about how you check whether a circle hits a rectangle. The way that I'm going to cheat and make this a bit easier is I'm going to check only whether the pedestrian's position, it's like the center point of its ellipse, is inside the vehicle that we're checking. So what we want to do is we want to define a check hit method in the pedestrian class that takes a vehicle as its parameter. Where should I put this? It could go in all kinds of places. I'll put it before handle input. I don't know. It does this one's, I'm not 100% sure where I should put it. And it takes a vehicle as a parameter. This is the vehicle that I'm going to check. Did I get hit by this particular vehicle? So how do I check that? Clearly I need an if statement, right? And if the if statement comes out to be true, then I'm going to say, yep, I got hit by it, so I died. I'm going to set my aliveness to false. So that's how the pedestrian dies. What do I need to check here? I need to check if my position, my x and y, I need to check if my x position is greater than the left edge of this vehicle and less than the right edge of the vehicle. That would mean I was within it horizontally. And I need to check also whether my position is greater than the top edge and less than the bottom edge. So there's four things that I'm checking, right? So it's if this dot x is greater than the left edge of the vehicle, which is vehicle.x minus half its width, vehicle.width over 2, that's the left edge. And my x position is also less than the right edge, sorry. So that's adding half the width. So that takes care of the horizontal. And is my y position greater than the top edge of the vehicle, which is its y, which is the center, because we're using rect mode center, minus half of its height. And is my y less than the bottom edge of the vehicle, vehicle.y plus vehicle.height over 2. And that's how we can check, is my position inside the rectangle that is the vehicle. If this is true, if all of these things are true, we know that the dot in the center of my pedestrian, its position, is inside the rectangle of this particular vehicle, whichever one it is, and therefore we're dead. This dot alive is assigned false to show that we're dead. Okay, so that's that old one. That's what is written here as well, of course. So now we just need to check what happened, right? So the first thing we want to check is the pedestrian dead? If they're dead, switch to the dead state. So that's going to be back in our main script. After we've done this thing here, where we've moved all of the vehicles, we've moved the pedestrian, we can check, did the pedestrian get hit by any of these things? So if the pedestrian is not alive, so not if pedestrian.alive, but if not pedestrian.alive, which means that they are dead, then we want to switch to the dead state. So state is assigned dead. The other thing we want to check, did the pedestrian make it to the top of the screen, i.e. they crossed the road? We can do that by checking, is its y less than 0? That would mean it had gone off the top of the canvas. So if the pedestrian's dot y is less than 0, that means it's made it to the top, and we should set the state to our success state, because they crossed the road like a genius. So let's go, and I think that's it, right? Let's see. Do we have a depressing commentary? Let's check it out. Oh God, almost got hit by that car. So I'm walking around. I mean, I should try and die, but let's check. Whoa, good God, that was a bit stressful. I'll try and cross the road first. Oof, that motorcycle is very close to me. Hey, I made it. So that's good. So we tested 1/2 of this thing. I'll reload. Now, can I get hit by a truck? I cannot. I'm not getting hit by the truck. Why is that? I think I know why. Do you think you know why? I think it's because I'm not very smart. In order to check whether the pedestrian is being hit by these vehicles, it's so funny that I made all of that effort trying to dodge these things and they can't even hit me. I needed to use the check hit method, right? I went to all of this trouble to check whether the pedestrian had been hit by any of the vehicles, and I never used it. And to use it, I need to check it against every single vehicle, right? If I want to check every single vehicle, I should write it inside this for loop that goes through every single vehicle. So let's add that. So we want to use the pedestrians check hit method. So pedestrian.check hit, since that's where that method is defined, and I want to check it against the vehicle that I'm examining or using inside this for loop. So pedestrian.check hit vehicle. That's the thing that's going to update its alive property if it gets hit. So that's why I was invulnerable to traffic without knowing it. Let's go back and check if that worked. So, whew, can I get hit by a car? Yes, I died. So sad. So this is actually, it turns out this is not the hardest. I mean, it depends on how good you are at this sort of, oh God. Okay, I was just about to say it was too easy, but clearly I'm not as good as I think I am. There we go, I made it. I'm a genius. So we could, of course, change how insane this road is to cross. We could up the number of cars and trucks and motorcycles. That should make life a little bit more alarming. Yeah, that's definitely less easy. Although I'm very good at everything I do, so I made it. So maybe that's too easy. Depends on what your view on road crossing is. I could also do things like change the speed of these different things. I could make everything twice as fast by updating them in their different things here. I don't want to make a motorcycle that moves at 20 pixels per frame. That seems ridiculous. But I could make the car twice as fast. So then that's quite stressful. Yeah, this seems harder. Oh God. Oh Jesus. Yeah. Okay, so this is very difficult now. But you know, for those who really like super difficult, oh God. Super difficult. I'm not going to try and keep doing this. You don't need to watch me playing this simulation. I will just admit that was quite hard. That's the end. That's the activity, right? We've got a basic kind of froggery kind of experience. Very stressful. So we're finished. What else could we do? Like, I mean, this is only a very basic simulation. There's clearly so much stuff that we could do. We actually did this thing. We tweaked the speeds and actual numbers of things. We could tweak their sizes as well. But there's all kinds of stuff we could do. We could make the cars move a little bit more erratically by using polar coordinates. We could do the same thing with the pedestrian. There is an Easter egg, I will just point out, since I just noticed it there. One way that you can cross the road completely safely is if you hit off the side of the screen like that, and then you go up. I'm going up right now. And eventually you made it, because there's no cars outside the screen, right? So they can't hit you. It would probably make sense to not allow the pedestrian to go off the sides of the screen. You could either wrap them or constrain them onto the screen if you wanted to avoid that. More interesting vehicles that move in different ways. Maybe you could have drunk cars, classic drunk cars, too much ethanol in their system. Arrange the vehicles onto roads so there's a little bit more structured. That makes sense. I love the idea of them tooting at you when they get too close to you. That would be a funny experience. All kinds of stuff, right? There's lots of stuff that you could do to improve on and make the simulation more and more fun and interesting and either depressing or not. Maybe you could make cars stop when they come near the pedestrian so that it's really easy to cross the road. That would be nice as well. Anyway, I'm rambling. That is everything. Oh, look at my face. Everything that I think I have to say about the activity. I found it entertaining. I hope that you did too. And I hope that you have a good time playing around with that new simulation. That's it. See you in the next video. Bye.